Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by Techstrong and Chronosphere. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting presentation for you today. First, I have just a couple of housekeeping notes to cover. Today's session is being recorded, so if you miss any of our discussion, or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, we want you to send those in to us using the Q&A tab, which can be found on the right side of your screen. The right side of your screen is where you will also find the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or just tell us where you're tuning in from. We do have a couple of polls that should pop up on your screen throughout today's webinar, so please keep an eye out for those, as we do want to hear your feedback there. And if you navigate to the handout section on the right side of the screen, you'll see the slides, which are available for download, as well as a series of links to help aid with today's webinar. So feel free to download those slides and check out those links. We will also be giving away 4 $25 Amazon gift cards, so be sure to stick around with us for the entire webinar. Our topic today is Goldilocks and the 3 levels of cardinality, getting it just right. And I'd like to introduce today's speakers from Chronosphere. Scott Kelly is a senior product marketing manager at Chronosphere. Previously, Scott was in product marketing at VMware, where he worked on the Tanzu Observability Wavefront team before VMware. And before VMware, Scott spent 3 years in product marketing at Dynatrace. So welcome, Scott.
Thank you.
And then next we have Ian Smith, who's field CTO at Chronosphere, where he works to deliver better insights and outcomes to observability teams supporting high-scale cloud-native environments. Previously, he's worked with industry engineering organizations on observability and incident response tooling in pre-sales roles at New Relic, Wavefront, PagerDuty, and Lightstep. So Scott, Ian, thank you both for being here. I'm going to let you both run away with it.
Thanks, Cody.
Thank you. And thank you, everybody, for being here. So today we're going to be talking about cardinality, and more specifically as it relates to metrics. As we alluded to in the title of this presentation, this is just like the fairy tale. Getting it just right is the goal, but it's very subjective. And we know everyone's on different journeys. Some are experiencing cardinality issues now, some aren't yet, and that's okay. So this is for both groups. So in this webinar, we'll be discussing, why cardinality is difficult to predict and what's causing it to be a problem now. What are the benefits and challenges? From a challenge perspective, what problems does it create? Potential systems and team impacts, business impacts. What are the barriers to getting it just right? And how do different organizations approach it for their needs? We'll talk about tips for managing cardinality using your existing monitoring observability tooling. And then we'll give you a brief overview of how Chronosphere can help you manage this. So first, let's take a look at from an overview perspective. So just to set the table here, what is cardinality? So cardinality is really a concept that's used to describe the number of elements in a set or other grouping. But today we're going to be talking about metric cardinality as it relates to observability. And if you look at the graph on the right there, in that sense, we're talking about the number of unique time series that are produced by a combination of metrics names, which we also call labels or dimensions. And in this sense, you'll see that, the cardinality of this is 9. But if we, and this is at a very basic level. So if we look at it, if we wanted to talk about it from a simple example using cars, let's say you had, the top 10 car brands here, your top 5 body types, and top 10 colors. Right? So what's the cardinality of this? In a very simple way, the cardinality of this would be 500, 10 times 5 times 10. But in reality, it's more complex, right? So Ian, why don't I turn it over to you to just kind of describe why it's more complex and why this is important.
Yeah, thanks, Scott. So in the theoretical example we've got here, the maximum cardinality is 500. But understanding what your cardinality is in reality or practice is really going to be very important in being able to control it when, or even hopefully before, that cardinality actually becomes a problem. So using the car as example, some manufacturers may not actually have all of these different types. So in the case of, say, Tesla, you may have a pickup truck that is hotly anticipated. But even if you do have that pickup truck, maybe it only comes in one particular color. So in this case, you ultimately have a bunch of theoretical cardinality that's not actually presenting itself. And so if you're trying to look for sort of like the highest number of combinations and where you might want to control your cardinality, Tesla and specifically the pickup truck may not be where you want to go and look.
Great. And so as we think about, why is this becoming a problem now, right? So it's been around for a long time, but cloud native is actually making this a problem. Recently, we've had, if you move from a monolith to microservices and to containers, it changes things. So Ian, why don't you expand on that a little bit?
Yeah, so you've got a lot more to monitor, right? Just simply the number of squares, the number of different business use cases, the number of different applications that you're running, and then ultimately the infrastructure that's underpinning all of that. So you're just inherently going to have a larger volume of monitoring data. Another complication is that you typically have ephemeral infrastructure. So some of it's going to live around for a while, some of it's going to disappear very quickly and come back, and some of it might grow and expand during particular times of the day. And you also have greater interdependencies. You need to have monitoring or observability data that allows you to understand what's happening between these in a much greater depth than you may have needed previously. And then when you take a look at all of this, you're ultimately going to have a lot more data, and obviously a lot more data means a lot greater cost as just a primary business outcome.
And if we look at this for a quick example of the difference in cardinality and equivalent-based VM versus cloud-native environment, let's talk a little through this to give people an understanding.
Yeah, so on the left, when you're operating on VMs, you may have your 10 HTTP routes or endpoint. You may have had your 5 services, and you may have operated this across 300 VMs. You end up with, in this example, 15,000 unique time series or 15,000 different aspects of cardinality. As you move the same workload or the same volume or the same kind of applications over to a cloud native environment, you may still have the same number of routes, you may have the same number of services, but you're now operating on a much higher number of pods. And you may also want to be able to add additional capacity to do things like experiments. Ultimately, in the cloud native environment, you're adopting this for more resilience generally and for faster iteration. So allowing your engineers to bring your competitive differentiation to market faster and iterate faster on those. So experiments tend to be one of those aspects. And as you can see, it's a theoretical example, but you can very rapidly go through to a much higher aspect of cardinality than you would have had with natural growth. And you can have this jump from 15,000 unique time series to 150 million. Ultimately, you're making these choices for valid business reasons, but you're starting to lose control and also insight into where is all of this coming from and how is it costing me all of this in terms of data and ultimately tooling cost as well.
Experimentations are a big part of this, right? So can you expand on that a little bit just to give people the understanding of, this, the fact that it's, smaller services, more agile, it gives people the ability to try out different things and test things, right? So can you expand on how that kind of impacts and how that's kind of out of control?
Yeah, particularly as you've moved to a cloud native environment where, as we said before, there may be an ephemerality. There's that greater option for you to do targeted testing or very narrow scope testing to be able to do things like do a small rollout of a new feature or a different version of code to see how it performs live in the environment without necessarily impacting the whole fleet. So shorter time to iteration and just greater opportunities to iterate and experiment mean that you're going to be able to give that freedom to your engineers to generate more different capabilities, test out different user experiences, and ultimately drive better differentiation against your competitors. So as you move to cloud native environments, you're generally going to want to be more agile and bring a little bit more experimentation to bear, which then unfortunately can have this pretty significant multiplicative effect on even just the base move from VMs to containers.
And that's kind of what we're seeing here, right? Is that this observability data is growing faster, 2 to 3 times faster in general than the business is growing. And, as recent polls have showed, one of them, 71% of organizations are actually starting to see this as a concern. And this is all recent in the last few years.
Yeah, absolutely. And lots of organizations that are undergoing a lot of business growth are also doing this migration at the same time. So again, you have this multiplicative effect where your observability data can be growing very, very rapidly compared to your overall business growth. DoorDash is a great example of this, one of our customers. They've had a massive increase, particularly in the pandemic, of their business. And their scale. They've also made this move to cloud native, and so there's a lot of additional architectural complexity. But on top of all of these sort of natural sources of observability data growth, they've actually been working hard to add more data into their instrumentation, so they have better insight into what's happening with their applications, what's happening with their users, and what's happening with their business. But unfortunately, because of all of this compounding growth before Chronosphere, is ultimately leading to a degradation in the engineer's confidence in that tooling, because the data was just being dropped on the floor, and ultimately they were having to rely on sort of workarounds to be able to solve incidents. And even with sort of all of this loss in data, the monitoring systems themselves were becoming highly unstable and just ultimately not reliable, which is not what you want when you've got a peak period such as Friday lunchtime and you're trying to dig into where a performance problem may lie.
Great. All right, let's move on to our first polling question.
Yeah, so as the polling question comes up, ultimately what we want to hear from you, the audience, is how far you are in your adoption of cloud native microservices and containers. And there's no right or wrong answer here. It's just simply sharing amongst your peers. So some of the options are your migration may already be complete. You're done. You've got everything in microservices and mission accomplished. Or maybe you are in an environment where you've made the biggest push already. Most of everything that can be readily migrated has been. Or you may be in sort of what I suspect is probably the most common grouping, which is the migration is underway. You're a little ways from the start, and you may be quite a ways away from the end of that particular migration. And ultimately, you may not ever get fully migrated because it's ultimately a choice about what makes sense, right? But there are also going to be a very large population of engineering organizations out there and businesses who are currently planning or considering a migration. And sometimes it makes sense to push that out a little bit. Maybe you want to hire, maybe you want to staff up, maybe there are other business objectives. But either way, we're definitely interested in hearing what you think. So looks like we've got some results through, and yeah, as we suspected, migration being complete is a relatively small number, but definitely applause and congratulations to you all. And then yeah, we have a decent population of people that have migrated the majority of what they're planning to migrate, and probably dealing with that long tail at the moment. And then the migration is underway. But I guess maybe I was a little bit wrong, but most of the attendees here, or I guess the largest portion of attendees, are specifically planning or considering their migration. So hopefully the conversation that we're going to have here today is useful to you in preparing. Yeah,
especially because from what we've seen working with customers that have further along the path, these are some of the challenges. So let's talk about some of the benefits and challenges of, cardinality. So first, we want to talk about the Goldilocks, non-Goldilocks cardinality, right? So everybody wants high cardinality, right? But what is that? Like, there could be too much, too little, right? It's based on each organization, right? So let's talk a little through this.
Yeah, so you can collect everything under the sun and try to shove it into metrics, but ultimately, if you're adding additional dimensions which contribute to that cardinality, so thinking about things like the vehicle type and the color, does it make sense? Does it actually help you? And if you add things, too many of those that aren't helping you, and they're very expensive in terms of their sort of explosive growth on your cardinality, you may end up with situations like I mentioned with DoorDash, where it can lead to system instability and ultimately degradation of the primary purpose of this, which is to be able to answer questions. If the people from the business or the engineering side can't answer their questions, and ultimately you have data in there that's not actually helping you answer any of those questions in the first place, then that's definitely a case of too much cardinality. But if you go the other way and you're highly restrictive and there are key questions in the business that just simply can't be answered, your system might be stable, you might have your cost under control, but your engineers or your business stakeholders are wasting a lot of time trying to answer questions that they just simply can't because the data is not there, then you don't have enough cardinality. A good example of this, if we think about experimentation, is if you don't have the ability to differentiate between user experience or the performance of a particular microservice who's running a particular version of code, then that experimentation is going to be, it's very difficult to understand whether experiment is working or not.
Great, thanks. So let's talk a little bit about why it's so hard to control and or predict. There are obviously a number of reasons, right? Services aren't created equal. Some are more important. Teams have different needs. They have, as we talked about, experimentation. Small changes can have a really big impact. I just heard about, a customer prospect they were talking to who someone added a timestamp and it brought down the whole system, and being unable to detect early. So let's walk through these, and can you get some color on each of these?
Yeah, I mean, ultimately, there's lots of different aspects to it, but I think the ultimate thing to think about is that there are lots of different uses and there are lots of different inputs of the cardinality. So you may have key services where it's really important for you to understand what is going on with this particular service because it's mission critical. But if you evenly apply the depth of instrumentation, so that's the definition of the data that's coming out of that service, and you might say, maybe you're tracking on a per customer basis. You might have 20,000 customers, 25,000 customers, and it's really important for a particular service for you to be able to track that. But if you apply that equally across every single service, including some that are not mission critical, suddenly you have this massive explosion of data where ultimately you just don't need it. So getting back to that too much cardinality kind of problem. Same thing, services are a particular perspective, but teams can also be a particular perspective as well. Maybe you have a team that's focused on e-commerce, and maybe you have another team that's focused on something that's sort of more back office. So needing to understand exactly what the team needs between e-commerce and like a back office backup team, they may have a completely different sense of the cardinality that they need and the dimensions they need to operate on. And of course, you can't just have sort of this same rules across every team. And so understanding, for example, if you're with a team that maybe has a huge amount of data, as you do those experiments and maybe you add just sort of like a binary, like, is this an experiment or is that not? You could just double your cardinality. And if your cardinality is making up 90% of what's going into your observability system, that could be massively detrimental. But at the same time, if you do this in a dev environment where it's a very small sort of impact, that's totally fine. And ultimately, a lot of these things come down to the tooling and the observability solutions generally don't give you that awareness. So fundamentally, what's going on? And then once you know what's going on, the insight to be able to really granularly understand, okay, what might I want to do with this? What kind of cardinality is useful or not? So all of these things, it's, what's the behavior of your teams? What's the behavior of your business? And then ultimately, also, what is your tooling able to do to help you in this awareness, insight, and control aspect?
I think one of the interesting things here is to think about too is that, talk about Conway's law, right? So as your IT or microservice environment gets more complex, so does the organization, right? So as we talked about the services and the teams, it's like a compounding effect almost. Would you agree?
Yeah, absolutely, right? The more interactions between teams, the more interactions between services, the more interactions between business units, and this can even be interactions on your external dependencies as well. Ultimately, it's a big reason why people move to microservices in the first place is that they want to be able to try and have teams narrow or focus down. But that does mean on the technical side, you have this massive explosion. You go from VMs to containers so that the scope of what a team does is maybe a little bit narrower than a big monolithic application on a VM. But in doing so, you have this massive explosion of interconnectedness and then the data on the underlying infrastructure as well.
And so let's look at the direct impacts of too much cardinality, right? There's performance issues. We talked about that a little. Anti-patterns, like what do teams have to do? What are we're talking about the observability team now, looking at this from a systems perspective, surprise overages from a cost. Talk a little bit about these things, what we've seen.
Yeah. So if you think about yourself as an engineer, maybe just an applications engineer who doesn't think about observability day in, day out, you're on call, you get an alert, and then you realize actually when you dig a little bit deeper, the alert has taken a really long time to fire because of issues with cardinality. Maybe there's just too much cardinality for your observability solution to process properly. So you've had ingestion delays, or maybe even just the query delays in understanding and processing that alert. You go to load a dashboard and the dashboard just doesn't load. You've got to go and narrow it down. By default, it's trying to load a 1 day period. You have to go and narrow it down to 4 hours, 6 hours to just get it to load in the first place. And even if it does load, it's taking 30, 40, 50 seconds. And that's obviously precious time when you're in an incident type scenario. So that's that instant kind of behavior. If you think about maybe more less time pressure, but maybe more frustration things. You're trying to do some of those experiments. You're adding cardinality to your instrumentation, and you do a rollout of that particular experiment, and you end up causing performance issues for some other team. You've got to suddenly roll back. You were trying to get data about that experiment. You don't get data about the experiment. You now have to figure out, well, how exactly can I reduce the blast radius or impact of my experiment? Not because it's performing badly, but just simply because the amount of data it's generating means that I can't actually roll this out safely. So now you're seeing scenarios where the observability data set and ultimately the problems with the observability tooling are causing behavioral changes with the what you're trying to build with the engineering team. Rather than serving the engineering team, it's actually altering their behavior, which is definitely a negative impact. And then the business, it may not be what every individual engineer thinks about, but definitely the observability team, VP of engineering, and maybe even, I know in some cases, a board, start asking, why is the cost of this particular thing so large? And we've definitely talked to organizations where the cost of observability, even just the raw licensing cost, let alone the people cost, the growth of that is double, triple, maybe even 5x what they're spending on, say, AWS or GCP. And that's where things start to get really concerning for the business.
So basically it's this, right? I like memes, so I made it into it.
Yeah,
this will be the only one.
Yeah, I made sure that Scott didn't put too many memes in here, but you're right. I think it gets a message across, right? Your stability, your reliability, performance, and cost of your observability solution can get absolutely clobbered by the runaway freight train that can be the growth in your observability data.
And so we talked about the impact on the team, but there's also a real business impact, right? So, these are things that get noticed at the C level, the board level, like upset customers, lost revenue, talent loss, which is a big thing, especially today for engineering talent, and less innovation. So let's walk through these a little bit.
Yeah, I mean, obviously, no one wants unhappy customers, right? As much as they may be difficult and demanding, but ultimately you want to provide those services, and particularly from the sense of software, you want the software you deploy to work for them. When things go wrong, you want to be able to solve them quickly. And as I talked about, having too much or too little is definitely that terrible moment. You might have a stable observability solution, but you may not have the granularity to figure out why a particular customer or set of customers is having problems, or even identify which customers are having problems. So this is not just having too much cardinality. It can be either side. As we said, ultimately it's a Goldilocks target. It's not just, oh, let's reduce at all costs. You can obviously miss revenue with dropping your SLAs and having that negative brand sentiment. It can reduce morale. And then I'm assuming most of the people listening in today are probably more on the technical side. And as we know, it's very difficult to acquire engineering talent, but quality of life of that engineering talent isn't something that can be taken for granted. And there's lots of different ways that can manifest. It may be that you're frustrated because you're constantly on call and you're constantly not able to solve the problems. It may be that you can't do the kinds of experiments you want to do. It may be that you have all kinds of constraints put on you, or ultimately the business isn't performing particularly well in relation to the things that we're talking about here. So it all sort of ties together, and it's not just the perspective of the individual engineer. It's not just the perspective of business stakeholders. Everyone in the business can be severely impacted by this, and obviously has a hand in solving this as well.
Great. And we have another polling question. This will be the last one. So how is your cardinality? How would you say? Would you say it's not enough? It's just right, too much, keeping this Goldilocks theme here? And we'll wait for you to respond, but
yeah, sorry, I forgot to take myself off mute. I was just saying that maybe we should have had another option, which was I don't know, and that can also be a scary option. But hopefully everyone's thinking that they have it just right, but maybe as they've thought through some of these things of not having enough cardinality or having too much, maybe there are different perspectives that lead them away from, well, maybe we thought we had it just right, but maybe we can't answer some of those key questions, or maybe it is frustrating our engineering teams.
I keep thinking about the abnormal, situation where they were basically at their limit, right? But they still didn't have enough. And so I don't know, that dynamic just kind of strikes me as interesting to, and how it differentiates based on the business, and how this is really subjective to each organization.
Yeah, I think abnormal is definitely an interesting one, where they, from an individual engineer perspective, they thought that they had it just right, but the business ultimately wanted to be able to provide per customer insight. And when you have thousands of customers and a highly technical product where you need to be able to sort of understand in a very complicated sort of processing chain, what is the experience of the customer at every point in that chain? That was something that the business wanted. Engineering sort of went, well, that's not something that's typical. So I think that we have enough cardinality, but there's a very valid case now. Now they're actually able, and we'll touch on this a little bit later, but they're actually able to deliver that kind of cardinality to the business. And then their engineering team have actually been able to make use of it as well, in the similar vein to sort of that granularity around experimentation.
Yeah. So it's interesting looking at these results here. If we were to overlay these with what we saw earlier, we have the majority are saying it's just right, but we also have a majority saying that they were just getting started. So be interesting we don't have the ability to look at this, overlaying those, but interesting results here. And there obviously there's a large group that's also not enough and struggling.
Yeah, for sure. And so I guess it looks about even between the just right population and those who really aren't in that Goldilocks kind of moment. And I would suspect, as you sort of alluded to, Scott, that maybe the folks who are in the just right category are those who, or a lot of them, are maybe staring down the potential of doing a migration. But it's definitely some interesting data.
All right, well, let's now talk about tips for helping getting it just right, right? So customers, we saw the polls. Some have said it's too much, some are too little. Yeah, others are earlier on the journey. So I think as we talk through these, there's kind of 3 scenarios that we've seen that are pretty common. And so let's talk through these, because I think for the organizations that are getting started early, they may not be encountering this yet. So let's talk through what these different scenarios are and how you can use your existing tooling to try and control. And for those that are, have too much or too little, it's the same scenario, right? So let's talk through these scenarios here. So the first scenario.
Yeah. So ultimately, there's that tension, as we just hit on the poll, is the tension between too much and not enough information. You pardon the horrible grammar, but it's there as a joke. But you have to remember that just having more data is not necessarily more better, right? And as we talked about, it needs to serve a purpose. And that purpose can't be the same for all teams. It can't be the same for all services. Ultimately, there does have to be an element of human judgment in there. So a good starting point is creating sort of a common playbook or framework on how you should use tagging or labeling in the environment, right? So for a particular service or particular use case, give examples, walk through the potential impacts, not just in terms of just the sheer amount of data, but like, what does it mean if you get this wrong? It could also be from the perspective of, maybe you want to get granular in a particular area because it's really important to the business, and maybe you want to get hyper granular in an area where it's very small sort of blast radius, but particularly in development environment. So being able to have all the detail that you want in development environment as you maybe want to iterate, and you can do all the, say, load testing on your experiments, can be really valuable. But then also making sure that that doesn't make its way to production and hit 300,000 containers and explode from there can be a really good idea as well. And then on a basic level, being able to control some of that data flow and just make sure that if there are issues where maybe an experiment has gotten loose, there is some sort of fail-safe where you want to be able to apply some sort of like rate or query limit to make sure that in the worst case scenario, there's a massive explosion of data, you don't cause like noisy neighbor issues.
And let's look at scenario 2. Too much cardinality, metrics is too much to manage at the micro level.
Yeah, so you want to be able to get an overall awareness of what's happening with your metric cardinality and overall all your observability data. You want to monitor the monitoring. So understanding what's happening over time, understanding broad growth patterns, and even being able to attribute it to particular teams or business units is a really good idea. And then ultimately, you want to be able to know whether your monitoring or observability solutions are up and available. And if there are problems that are the intersection of the sort of growth in your metrics and your uptime and availability, then you need to be able to deep dive then. You don't want to go and sift through all of your metric data all the time. That's really not the purpose of all of this, but you need to be able to go and dive deep once you do understand there are problems or there's the potential for problems. And so once you have that insight and you've dived deep, you then do need to be able to take some sort of broad level approach to address this at the data level. Oftentimes, particularly with open source solutions or even the vendor solutions out there, if you do get a massive explosion of data that you've somehow become aware of, the only thing you can really do is say, okay, well, I need to go back to the source and I need to go and rip it out. And so that's the kind of scenario where you have that rollback perspective of, oh, we've released a new version of the software, all the users are using it, and we are getting some level of useful data, but the cardinality is incredibly expensive. A good example is being able to aggregate that data in real time so that you get the aspects of cardinality you care about. You can't just drop all of the raw data. You can't just cause a rollback, but you can aggregate the data down into its most valuable form.
Then if we look at our third scenario, about making it a team effort, and I think for the organizations that aren't as far along, as we talked about how the organization will get more complex, more teams, this becomes a real important one. So let's expand on this a little bit.
Yeah, and it's somewhat related to part of what we talked about in scenario 3, right? Is as you build out, say, a framework, getting buy-in from the teams that they're actually going to adhere to those parameters, they understand the impact of that, is really important. So the framework is sort of like the book, but then getting everyone to buy in and adopt the book and those rules is really important. Ultimately, a lot of organizations are moving to a central observability team perspective, or even having SRE take on the responsibility for observability, maybe in organizations that aren't large enough for a dedicated observability team. But if you simply make it the responsibility entirely of that team, you're going to concentrate all of the burden, all of the work, and essentially bottleneck on them. Whereas you want to be able to distribute the knowledge, the insight, and even the capacity to address these problems across the organization and hopefully avoid them before they actually become problems. So obviously doing this, it's not just about pushing the work out, but you want to be able to get leadership to buy in, right? You want to be able to make it so that they're reinforcing the importance of this. And when a team says, look, I have to choose between addressing some of these cardinality problems, or I have to, you do some other task, you're making sure that that's properly weighed up. It's not necessarily cardinality is the only problem that you want to deal with, but making sure that leadership understands that there are going to be negative impacts if you don't adhere to these things and weigh them accordingly is important. Also tooling, right? You want to be able to automate this. You want to automate the general awareness so that you can get alerts and dashboarding. You want to be able to automate to a degree the ability to dive deep. You don't want it to be a highly manual effort of someone doing the equivalent of grepping through terabytes of data. And automation tends to lead to, particularly with engineers, like, oh, I could build it myself, right? But there are solutions out there that mean you don't have to build this yourself. And ultimately, is your business focused on building capabilities for your customers, or is your business focused on building internal observability tooling? Presuming is probably the first. And then, of course, in general, being able to encourage just doing things responsibly, right? And iterating. So rather than trying to shove a square peg into a round hole, how do we make sure that everything that we're doing, particularly around observability, is supporting the goals that we all have to make the business successful and reduce things like burnout on the individual level.
Great, thanks. All right, so let's shift a bit and let's talk about Chronosphere and how it can help. But I think first, let's just give the audience a quick overview of Chronosphere and its capabilities. Many may not be familiar. We're a relatively young company, but it'd be great for you to just give a brief overview of how the platform actually works.
Sure. So Chronosphere is an end-to-end observability solution. End-to-end meaning that we ingest the data, we process it, store it, give you the ability to query it, give you dashboarding, give you alerting, and all those kinds of things. Ultimately supporting the ability for you to get notified about your problems, triage them, and then do root cause analysis. And we've talked a lot about metric data today, but Chronosphere also ingests metric data and tracing data together. And we're really focused on doing this for sort of solving for the biggest problems. And the biggest problems aren't necessarily scale problems. We obviously handle scale really, really well. But the biggest problems are people problems and organizational pain, right? It's not just about the sheer amount of data you can shove through a platform, but are you solving real issues? As we've talked about, burnout is really important. The ability to actually solve problems is really important, not just at the technical level, but at the business level as well. So as you can see here in the middle, there's some key aspects that we think are important on the translation side of things, being able to do groupings and assign your costs and usage, having a best-in-class data store. It's built on technology the founders created at Uber at true planetary scale data volumes, and then a control plane. As you've probably noticed, controlling this data is a really important aspect, and we'll definitely dig into that a little bit more. And I just want to underscore, maybe as we move to the next slide, all of this is aligned around open source standards. So being able to ingest things like Prometheus data or OpenTelemetry data and use your existing alerts and dashboards that have been defined with those open source tools.
Yeah, I think that's an important point. All right, so let's just, just to recap those common scenarios, I'll let you talk through how Chronosphere actually addresses each of these. So let's start with, we talked about observability data growing. So just give an overview of, give an example of how how Chronosphere has helped in this situation.
Yeah, so as we've talked about, the metric growth over time is a really big issue. Chronosphere's control plane in particular and the associated tooling gives you the ability to really bend that curve down so that you can get something akin to or even below the growth of your business and have your metric growth sort of be below that curve and not deal with a lot of the problems that we've been talking about through intelligent use of the tooling. So we do this with having server-side control. So we're not forcing you to deal with the problems we talked about, like, oh, hey, you finally see a problem, now you're just going to do a rollback or you've got to change your instrumentation. We can dynamically change the shape of your data as it flows through and is stored. We can pretty much guarantee you that the impact of high cardinality spikes is not going to present itself as overages, as is very common with observability solutions in the vendor space. And of course, the alternative in the open source space is ultimately you have really high system instability, and it's not, the observability solution is not available when you need it the most. So we do this through a variety of different controls, but ultimately, being able to drop the offending cardinality while retaining the data that's useful is really the key here. Now, it's not just dropping data naively. It's not saying, okay, here's expensive data, let's just drop it, but it's actually being able to extract the valuable aspects of that data and discard the sort of more expensive, less useful aspects of cardinality, giving you the potential of retrieving it later or ultimately changing your instrumentation when it's suitable for you. A good example from a customer perspective, as we mentioned before, abnormal security. As I mentioned, they have a lot of cardinalities critical to their business and being able to differentiate against the competition and provide an excellent service. They were running open source monitoring metrics capabilities on the largest instance type that's available in AWS. And the performance for key dashboards was really bad. So business critical dashboards that were critical to the engineering team for overall insight as to what was happening. If they extended those past 30 minutes, they would have just completely failed to load. And so they had gotten to a point where any additional cardinality was by default just discouraged. So no engineer should be adding any additional cardinality, mainly because every time they were doing so, they were taking the system offline. So the lack of availability and performance meant that they weren't able to rely on their alerting, they weren't able to rely on the dashboarding, and it was really starting to impact the customer outcomes that the business had really geared towards as key goals, right? Being able to provide a really solid service and capabilities to their customers. So despite a lot of really smart engineers, they ultimately just didn't have the tooling to be able to gain visibility into what was going on with cardinality. And then ultimately, even if they were able to determine a particular metric or particular label was high cardinality, they couldn't control any of that. So they were burning a lot of engineering time with not a lot of return in this environment. So they're able to use Chronosphere to be able to address this, and we'll walk through some of the things that they use and that is available in the platform around this awareness, insight, and control for your observability data.
Yeah, well, that's tough as a growing, fast-growing new business. So, yeah, let's get into that. So, here, talk about how awareness and real-time usage metrics work.
Yeah. So, in the use case of things like your cardinality, your awareness, it requires real-time metrics about your usage. So this example, it's a screen snap taken from a dashboard. It's a much more comprehensive dashboard, but it's one that we generate automatically, and the metrics are also generated automatically about the data that you're feeding into Chronosphere. You'll notice that there's some breakouts, your different teams, as well as an unknown grouping. These groupings you can define based off whatever label that you care about. And it could be a team, it could be a service, it could be a business unit, whatever makes sense to you, and it could be combinations of those as well. You can, of course, because they're just standard metrics and dashboards, you can use these metrics and dashboards to create your own views. So you could create a view that's specific to a particular team or a particular business unit that's made up of a bunch of different teams, or for particular use cases. Cardinality, data rate, and a bunch of different other things are available on this dashboard and the out-of-the-box metrics as well. Importantly, though, you don't just have to come in and take a look at this dashboard. Because they are standard metrics, you can alert on them. So you can set up scenarios like individual teams can be notified based off the rate of change in their metrics, or just overall being close to the limits that you'd like them to stay under. So moving on to insights. So having the high level metrics isn't enough, as we talked about before. So even if you were able to generate usage metrics about every aspect of your cardinality, then you'd ultimately just sort of exacerbate your problem. You'd have more metrics about your metrics than you need. It's not really the way to approach the problem. So we built a metric profiler that allows you to profile your metrics interactively as they're ingested, processed, and stored. This is again a screen snap or a screenshot, but this will update live every second as you're watching the flow of data into Chronosphere. So the portion on the right is just a general volume breakdown based off your named metrics, and they're grouped by that particular name. You can see the average data points and the current data points per second. And on the left is a cardinality analysis on this data set. So which labels exist, what is the coverage, so the percentage number is the percentage of metrics that this particular label appears on. And then how many unique values of that label do we see? So in the one that we've highlighted here, ID exists on 57% of the metrics that we're currently ingesting, but has 392 values. So it's a very high cardinality label, and it only exists on just over half of those. So if we wanted to sort of target things that are probably leading to a significant increase in cardinality, ID is probably one of those that we want to take back to the team that's generating this and ask them what's going on here, and is this truly useful cardinality? So ultimately, the profile is very helpful at identifying those sources of potential cardinality. It's not necessarily saying let's just drop all of it or let's get rid of the data that has this. But the next part of it would also be additional tooling that we have, which allows you to find the cardinality you're simply not using in your dashboards, alerts, or other queries. But we'll save some of that for later. So next, moving on to control, which, as I said before, it's that ability to reshape your data to sort of extract the greatest value out of it, not just simply dropping it. So some of that is being able to combine, downsample, and aggregate the metrics. You can remove particular labels, you can adjust retention and resolution. And importantly, all of this happens inline before storage, which is ultimately the thing that actually costs real money. So if you transform all of this using the control plane, you might have 100,000 data points per second coming through the front door, and you may be able to very simply halve that. And that's a pretty typical out-of-the-box kind of scenario for our customers. And that 50,000 data points or writes per second is ultimately what's going to cost you Chronosphere licensing. Other solutions ultimately neglect this, and so other solutions generally neglect this because they're going to focus on just general optimizations of query performance and compression, rather than addressing the root cause of the issue, which is that the data that's being generated is not valuable in its original form. In some extreme cases, this has enabled our customers to get up to a 98% reduction in data volumes, but we typically see 50 to 60% reduction without any extreme work or losing any useful fidelity in the data set. So let's give you an example of that in practice. So again, a screen snap of a dashboard, and you'll notice on the left, it's all raw data. On the right, it's the aggregated version of that data. So working from the top, the process transactions graph, which is typically the kind of thing that you'd see on your dashboard. Maybe it's a high-level business dashboard or engineering dashboard. And you have a lot of data that's feeding into this because it may be over many clusters, many containers, and maybe many instances of your application. Now you'll notice that visually these are the same. It's the same graph, it's the same visual result that is being output to the dashboarding. And that's important because this is how you're consuming the data. This is how the data is actually valuable. In the middle, you can see the sort of cardinality count that's powering both of these graphs. And the one on the left is obviously much higher, several orders of magnitude more cardinality and more data involved. And at the bottom, you can see a breakdown of the query time. And this is just pulled from the dashboarding engine itself. So you can see the direct query time that it takes to load this particular graph at the top. And so the one on the left, it's over 6 seconds, and the one on the right is 108 milliseconds for the same visual result. Now, from a performance perspective, you can see there's a huge dramatic improvement. And this can be the end of it. It may just be you have this high-level dashboard, maybe an executive dashboard that you really need to optimize the performance for. You can imagine if you extended this out past 6 hours, maybe you extended it out to 7 days or 30 days, the raw performance would start to get to the point where it's really just not acceptable, and you'd have to sit around or potentially deal with a scenario where it just doesn't load. And so having that executive dashboard load in under a second on the right is definitely that kind of experience. But then the next step that you can take is you can potentially also drop the raw data before it gets stored. And this is a key important aspect that's different from, say, other solutions that might come to mind, like Prometheus recording rules, is you can drop that raw data. And if you think about sort of the magnitude of data in that sort of cardinality section that you would be saving, then that gives you an understanding of the impact that aggregation can have on not just performance, but also on cost as well.
Great. And so just to recap, as we're getting close and we're going to be doing Q&A soon, so please and put your questions into the console so we can answer anything. Looking at the benefits we talked about, you can control your observability data, compatible with open source, makes it easier for engineers to get on board, scales very reliably, 5 times more than alternatives in the market. And really, at the end of the day, it's about remediating customer issues faster, right? It's about engineers being able to keep those customers happy. So we have some assets here that you can also find in the handout section, I believe, and you can go review those case studies that we talked about and other resources. If you would like to see this in action, please schedule a conversation with us and we'll set up a demo and can walk through and give you a demo of the environment. But now let's move on to Q&A and give people a chance to put that in the console.
All right, and so while we wait for a couple of questions to come in, I do see we have a couple, but I'll go ahead and take this opportunity to remind everyone that this session was recorded. So following this webinar, you should be receiving an email with a link to access the recording on demand. You can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. So let's take these questions from the top. How do Chronosphere's roll-up, aggregation, and downsampling capabilities compare to Prometheus recording rules?
Yeah, so as I mentioned, maybe if you go back a couple of slides, Scott. As I mentioned, one of the key differences is that while recording rules can be used to speed up queries, they don't have the ability to impact sort of the total volume of data in terms of a reduction perspective. So you still have to store all of the data, and then Prometheus essentially has to query that data back out and then write a new set of data to answer sort of your recording rule question. That introduces additional latency, so it can mean things like your dashboards are going to be a little bit behind, your alerts aren't going to fire as quickly. It also increases the amount of query load that you have on a system. So if you're sort of running close on system resources in Prometheus, it can be a tipping point. And ultimately, it's just going to add more data as opposed to giving you the ability to drop the raw data and only store the recorded result.
All right, and our next question reads, how can you know if cardinality is used or not?
Yeah, it tends to be a pretty difficult thing to ascertain. It's in the open source world, it's sort of like not really an answered question. And then in the vendor space, it tends to be a scenario where there may be actually incentives for the vendor not to give you that insight, right? If you're sending them a whole bunch of data and they're charging you for it and you're not using it, then it's actually just like a great revenue increaser for them. What we've actually built at Chronosphere is a bunch of different tools. One example is, and I didn't include it here just because in the interest of time, is the ability for us to take, say, your dashboards and your alerts and automatically give you an analysis of which metrics are not being used. There's also additional tooling around our aggregation capabilities that allows us to analyze the queries that you're making, whether they be dashboards, alerts, or ad hoc, and be able to take a look at the difference between what you're querying for, such as I want to group by cluster, and take a look at the data that's stored and say, well, there's actually instance cardinality here that you aren't using. And we're able to take action on that and be able to provide a really powerful aggregation outcomes on that, both for performance and cost reduction.
All right, so while we wait for any last minute questions that the audience may send in, I'm going to go ahead and give away a couple of gift cards. So these are for 4 $25 Amazon gift cards. Our first winner is Igor B. Our second winner is Ritu M. Our third winner is Hannah H. And our fourth and final winner is Gonzalo J. So to the 4 of you, congratulations. Please keep an eye on your inbox to claim your gift card. But if you don't happen to find that email, please check your spam folder.
Hopefully they get it today because Prime Day started.
Oh, it sure has.
Yeah.
Good call out. Awesome. Well, Ian and Scott, I'm not seeing any more questions at this point. So do you guys have any parting words or anything you'd like the audience to know before we close out?
Ian, you go first, and I can.
Sure. Well, hopefully this has been an interesting sort of conversation. Thanks for sharing your perspectives on the different polls, and let us know if there's anything else that we can assist with at Chronosphere.
Yes, thank you very much for attending. I know that we move fast through some of the Chronosphere capabilities. If you would like to see, have a deeper conversation, see a demo, understand more of the complexities of the, how the product actually works, please do reach out to us. There's a link that you can do that. You can also go through our website, and we'd be more than happy to have further conversations. But thank you very much, everyone, for your time today.
Wonderful. I'd like to thank Chronosphere for sponsoring today's webinar and making this presentation possible. Scott, Ian, thank you both so much for taking time out of your busy schedules to join us and to share your expertise. And to our audience, we really appreciate you spending time with us today. We ask for one extra moment of your time to fill out a brief post-webinar survey that will pop up on your screen here in just a moment. But otherwise, we do hope to see you at an upcoming Techstrong learning program. Everyone have a great rest of your day.
Thank you.